Hi, thank you all for coming. My name is Francesca, I'm from Cortical, and I will present what I've been working on for my bachelor's thesis. It's a prototype for a graph-based geointelligence engine. All right, so today we will have an overview of what this is all about. Then I will walk you through the process of the development. Then I will touch some theoretical key concepts behind what I did. We'll have a demo and then some Q&A. So, everything starts with what and why. We need to know what we did and why we did that. The graph-based geointelligence is all about analyzing Romanian businesses and their correlations of financial patterns. We wanted to see how companies connect based on their financial scores. And why we did that? Because we think it's important for business intelligence purposes to be able to identify the market trends in specific areas, maybe some partnerships between companies, and analyze the competition. We are Cortical, and our motto is geoinformation is our middle name. So we constantly try to develop new products that help businesses manage their geospatial data. We already have two established solutions. We have Carta and Graph. Carta is the backend for geoprocessing, and it performs all kinds of spatial analysis, especially in the area of risk management. So now, building upon that, we want to take our development further and enable network analysis. So this is what it's all about, investigating how we can integrate networks into our further analysis. I will walk you through the map of development, how we did what we did. First, we got the data that we processed. It was a process of acquiring the data from the Romanian government, business data with all the financial scores from the year 2021. Then we did some graph modeling. We added the companies to a graph database, and there we modeled relationships and all the needed pre-processing. We created the relationships between the companies based on financial patterns. Then we did some community detection to have the relationships pre-computed and stored as simple indexes in the database. We built the engine's architecture. We implemented it. Then we integrated the processing functionality, which is a location-based processing tool. And now we are ready to take it further and develop it as a product. So, a bit of the theoretical part behind. The main idea behind this prototype is community detection. So we have a network which is full of relationships between all kinds of financial scores. But it's a bit difficult to make sense of it. So intuitively we can identify some communities that are within that network. But how does a computer make sense of this? We applied a community detection algorithm. And community detection algorithms actually work on some graph projections. So we chose the Louvain method as a community detection algorithm. And what this does is basically identify communities within a graph projection of a network and build and add some community IDs in the database as node properties, so it's easily queryable and it's better for storage as well. So, about the graph projection, this is how it works. So you have the original network, which is really dense with all kinds of relationships. But in order to run the Louvain algorithm on a network, you have to kind of isolate some properties that you want in that network. So we chose to project some graphs on specific relationships. As you can see, in the first network, it's all of the relationships there, but here it's only one that's the focus in the graph. And based on a network with a single relationship, we can identify communities through that method. As you can see, the algorithm detects the communities, assigns an ID to each of them, and then all of the nodes from community 1 will have a property saying that this relationship, for example, is between the net profit, so companies which have a similar net profit. So all of the nodes will have the community ID assigned to them. This, as I mentioned before, is important to have them stored in the database as node properties for fast queries and memory optimization. It's easy access, and it's also easier to manage relationships. So we go from the graph data structure, which is based on nodes and edges, and we simplify it as a simple ID. As use cases, what are the results? So what does the engine actually do? It does graph analysis and a location-based report. So you can see on the map a network of how the companies in that area relate to each other. You can choose between different financial parameters, and you have different visualization levels. You can visualize it on a node level, you can visualize it on a cluster level, and it's customizable. And then, since we want to integrate business intelligence, but it's still a prototype phase, we generated a location-based report. So someone can have, the user can have the data of the companies within a specific parameter, and then download it as a CSV and further analyze it in whatever business intelligence engine they want. All right. Now I have a pre-recorded demo. I didn't want to rely on the internet. Okay, so you can see the engine takes your coordinates. I recorded it from Kosovo, so it wasn't accurate. Then we select some financial patterns. There's the report. We have the selected properties only. You can download the data, only the data from that range. And we can visualize the relationships in more ways. So whatever is of interest. And then there is the data about each company specifically. And this is the cluster level. So as we can see, we don't have relationships between claims for, okay. Here we can see what this means is we see the claims relationship, how the companies relate with the claims in the industry of hotels and restaurants in an area of clusterization of 150 meters. Yeah, so basically all the clusters that are blue contain companies that are hotels or restaurants, and all the clusters that are gray do not contain them. But as you will see, you can see information about both types. You can see statistics and the number of relationships by which they are connected. And again, you can change the industry and also see some reports for different clusters. And then you can change the parameter. Here there are, for example, there are no companies from the domain of agriculture, silviculture, and fishing. So all the clusters are based only on distance. And that's why they are represented with gray, as the legend tells us. But we can still see statistics on that. Okay. So, as we said, we want, this is one of the products we offer from the business intelligence domain. And to this point, it's only a prototype, but we want to develop it and make it a product of its own. And for building the whole engine, we used only open source technologies and or variants of open source technologies, because Neo4j is not really open source, but it has the option for, we used it with Docker, and we used the open source variant of it. And for building the engine, we used Angular, Golang, message queuing with RabbitMQ, PostgreSQL, Python, of course, and for the maps we used the leaflet library for visualization and operations on the map, and we also used the base map from Carto for developing it. So, yes. This would be it. We have a QR code that will take you to the website, to Particle's website, and we also have our LinkedIns and contact information if you would like to ask us anything. Thank you.